And we're back. Here is continuation in class 6. Come on, focus. Focus. All right, class 6. This is video 3, and we're going to do some more, doing another example using velocity field and maybe some MATLAB here to try to describe some kinematics, fluid kinematics. So the components of a velocity field are given by the equation where we have u. So that's the x component of velocity can be found by an equation, or it can be described by an equation of x plus y. And v, so the y component of velocity can be found from x times y cubed plus 16. Okay, so this, once again, that in video 2 we did an example where we had another set of u and v. But here's a different one, and this time we want to determine the location of any stagnation in the flow field. So we want to try to find a place where the velocity is equal to 0. Notably, this is steady flow, right? So if anybody asks you, is it steady flow? You'll notice that these are not dependent on time. If they had a time inside the equation, they would be, right? So stagnation occurs. That's a G, stagnation. It's a nation full of stags, maybe, I don't know. But anyway, that occurs when the magnitude of the velocity, aka the speed, is equal to 0, right? So that would mean that if we were to put in these components right here, that we'd have x plus y squared plus xy cubed plus 16 squared. That has to equal to 0. Now, the only way, these two parts can never cancel each other out because they're both squared. So regardless if this was negative and that was positive or what have you, there's no way. So the only way that this could ever occur is if both parts equal 0. Right? That's the only way that you could get that to equal to 0, and you could try to argue for yourself how that would happen. So that would mean, well, we're going to set that x plus y is equal to 0. Therefore, x is equal to negative y. And then v is going to be xy cubed plus 16 equal to 0. And therefore, xy cubed has to equal to negative 16. So if we want to find the place where this occurs, both of these things occur, we could just go ahead and plop the x into here and say that we have, okay, so we have a negative y from here times y cubed is going to be equal to a negative 16. Well, that's the same thing as saying, you know, the negatives cancel out right there. So we have y fourth is equal to 16. So y is plus or minus 2. Right? So therefore, the locations that you can expect is either going to be, so it's either going to be at, so there's a stagnation at 2 and negative 2, and negative 2 and 2. Those are the places that you can expect this to happen. And we could try this to see now, because this is sort of a boring thing when I first did this example, but I was like, oh, you know what I'm going to do? I'm going to make a plot out of this, another MATLAB plot out of it. So I went ahead and I decided I created a thing called spacing. So I decided my spacing is going to be 0.1, and I decided to make limits of 4. And so here's the plot I tried to create with this. So I created a mesh grid where I went from the negative limit to the positive limit with a spacing in between. So this is just a series of numbers of x's and y's. And then I found u's and v's by taking the respective x's and y's and creating them. And then, of course, in order to do the v1, I had to do a dot times and a dot to the cube right there. So that what that does is does the individual ones themselves, not trying to do the matrices operations, but it does the individual parts together, and plus 16. And then I also took found the velocity as a the square root of the magnitudes of these two components right here. So first off, I plotted out, and it's tough to do. I tried it with a bunch of different spacings to actually get to do, but it's hard to see. But I did a quiver, and these are all little tiny arrows right there. And you can kind of see where there's actually kind of like these little blank little sort of areas, but the only spots that are have the magnitudes of O and 0 and 0 and 0 and 0 are that -2 and 2 and 2 and -2. And here's all, I also did a contour on top of this with that V, and here's the number of lines. I put 20 of the these kinds of V lines. So this right here is also another I'm trying to sneak at the word. This is also another a grid of values right here, or the V. So it's the velocity at every one of the velocity magnitude, I should say, of every speed at every one of these little locations right here. But these are the only spots right here, these two stagnation points through in there. So let me pause this and see if I can connect to my computer back at work and pull up MATLAB. I should do this on the web-based MATLAB, but I gotta connect to my computer remotely from here. And sometimes it's been crashing my computer, so I hope I don't have to redo this whole thing. I'm gonna take a risk. Okay, so let's hope this will continue to work right here. So anyway, here is my MATLAB code for this example, and I'm going to run it. Let's run it, and let's see, we'll blow this up right here. And what we could do is we could take a quiver. Let's see, not a quiver, a data tip right here. So the data tips can be found by sliding these things around. Let's see. It's not going to let me do it. Is it? I think sometimes it's just a lag. All right, so there's the data tip, and I can move him around, and I can find where. There you go, right there. So there's a reference for the thing, and you can make another one too. I'm told by holding down Alt, find a good spot where that thing turns into that. There you go. And now we can move him, and we can find what the value is at a particular spot. So there you go. Boom, right there. And what's interesting to me is that these stagnation points, regardless of how close the grid is, let's see, I'll move these down to here. If you go to the V, right here, you can find these by coming down and could probably find them somehow. Let's see. I guess I have to kind of go over here. And I think the other one, the top one is like to the top right in there. Not doing a great job showing this. So what is the extent of this? It goes to 82. So it's probably somewhere right around there somewhere. That you could find in this matrix. Not doing a great job here. There, we'll try to find this one over here in the bottom right-hand corner, or somewhere up in there. What was interesting to me is that it doesn't really quite get smaller and smaller all the time too. There's that 65. I saw that in the other one. But it's in the lower right-hand corner somewhere. All right, so this is boring. I don't like boring videos. I'm sure you don't either. I found it, though. I swear I did. Last time I looked. But I was looking about the values of the speed right around in that area. No, it's got to be down here somewhere. Maybe a little bit further up. There it is, right there. So there's the bottom right. I think it is, or it was the top. Yeah, something along those lines. Sure. And then you could go find this one over here somewhere. Yeah, there's another one over here. You could trust me. Maybe you could trust me. Yeah, I'm still looking for him. There he is, right there. But you can see that it doesn't, like it doesn't seem to. I guess it is sort of small right around those locations. But I wanted to visualize that one a little bit better, to tell you the truth, just to get a better sense of why it was 0 in that spot. But those are stagnation points from this example. So let me close this thing down. I don't know for how much longer I want to continue, because I could crash at any moment. I guess I'll go and talk about the acceleration field. I'll talk about that in the new video right here. So that I'll just let that be a freestanding example by itself.